Hi, I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. This time we'll create a day and night post-processing shader. As always, a short disclaimer. This tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths, so if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you. Now in this tutorial I don't plan to explain a lot on how to code a shader. We've already learned nearly everything we need to create a day and night cycle shader, so I'm not treating this video as much as a tutorial on shaders, but understand it more like a walkthrough on this effect and as an exercise for you. Also, the shader itself is really simple. Most of the code is in the object's events and not in the shader. I might add another day and night cycle shader when we learned to use text chords and how to implement additional textures, but I'm not sure of that yet. I'll first have to learn more about lookup textures or lookup tables. So let's first think about what a day and night shader should actually do. Colors need to be tinted on different day times, something like pretty much white at noon, yellow at afternoon, purplish at dusk, blue at early night, dark blue at midnight, blue at late night, orange at dawn, and yellow in the morning. And contrast, saturation and brightness need to change as well, I guess. And at night, I think very light colors need to pop out a bit to make it look like they reflect the moonlight. Now I won't add a lighting system in this shader, though that would probably enhance the effect a lot. But I think that would easiest be done with texture coordinates and we're not there yet. In this tutorial I'm not going to use the usual base project file for this series. Instead, I took the usual base project, removed things we won't need and added stuff we need. A download link for the base file for this tutorial is in the description of this video and I strongly recommend to use it for this tutorial. Let's get an overview of what's in the project file already. As sprites, aside from the UI stuff, we got two tile sets. One is for the environment. It's a great tile set created by Michele Bughelli on OpenGameArt. I'll leave a link to Michele's OGA profile in the description of this video. The other tile set is a really simple 3-tile tile set for some star reflecting in the water at night. Then there's 3 empty scripts prepared. We're going to write those during the tutorial. Same goes for shaders. 2 pass-through shaders with a description in them already. Then there's a controller object, setting up some basic stuff to exit the game on escape or back button on Android, and setting up display and dimensions. Then the slider object, which we use to advance the daytime. And a nearly empty object which we'll use to apply the day and night shader. The room is finished with all the tile sets and objects placed already, however the reflection layer will be turned off at first. Now let's start coding. First thing we want to do is setting this up as a post-processing shader. This means we're not going to send each sprite through the day and night shader. We're drawing everything to the application surface as usual, and then after the normal draw events, we draw the application surface through the shader to the screen. So the first thing I want to do is disable the automatic drawing of the application surface. I'll do that in the create event of our day and night object. Application surface draw enable, false. I'll also re-enable it in room end event. Application surface draw enable is true. And in draw GUI event, I'll set and reset the shader, and in between draw the application surface. To make sure GUI and view and window are of the same size, I have already set the dimensions of everything to the view size in the create event of the controller object. So if we run the game now, everything looks normal. The only difference is we decided when to draw the application surface and we sent it through our shader, which at the moment is just a pass-through shader. Now to set up colors. Before that, let me quickly explain how this system will work. We're going to set up some key times, like keyframes in an animation. Let's say we set 3 key times, 0, 1 and 2. So key time 0 would be midnight, key time 1 would be early morning, and key time 2 late afternoon, each 8 hours apart. We're going to set up a color for each key time. Our timer, global.slider1, will then cycle through 0 to 1 and 0 to 1 again, where 0 would be midnight, a third would be early morning, 2/3 would be late afternoon, and 1 would be midnight again. In step event, we'll mix the colors of the 2 key times we're currently in between and pass that color to the shader to tint the image. So in example at noon, we'll mix the color of early morning and late afternoon. Then we'll create a system to add as many key times as we want. I'll add 8 in this tutorial, setting a key time for every 3 hours, but you could add less or more if you want to. After setting the colors, we're going to add more things to tweak, like contrast, brightness, saturation for each key time. Then we're going to increase the brightness of lighter colors during nighttime to simulate moonlight reflection, again based on key times. And in the end, we're going to make the water reflect stars in the night sky. So the first step will be to set up those key times and their colors in Create event. We'll need a handler, uCol, for the tinting color and its uniform col. We'll also need some additional variables. Color mix equals -1. That's the mix of the previous and the next key time. Color array 00 is undefined. That's the array storing colors for all key times. Key previous is -1. That's the key time we just passed. Key next equals -1. That's the key time we're approaching next. To add key times, we'll use the script add key time. Let's add some colors to test. The first color, 10, 70, 200, is for midnight. It's a dark blue. The color 250, 235, 200 is for dawn, and it's a yellowish orange. And 250, 240, 200 is for late afternoon and pretty much the same at the moment as for dawn. But we'll need to write the script before this works. So I'm setting up 3 parameters, R, G and B. Then we need to define which key time we're setting. If color 00 is undefined still, it's key time 0. Else it's just the next key time. And finally we set the 3 color channels to the 3 parameters. I like to pass the colors in as a number from 0 to 255, but the shader needs them to go from 0 to 1. So we'll just divide their values by 255. Now the key times are set up. The last thing in Create event is to store how many key times we got now. Number of key times is array height 2D of color. Now to the step event. Here we will mix the colors. First let's get the current time from global.slider1. Then we need to know the previous key time. Key previous is min, floor, time times number of key times, number of key times -1. Time times number of key times will give us the time in key times instead of 0 to 1. Flooring this returns the previous key time. But to prevent an out of boundaries error with the color array when time is 1, we need to make sure key previous is smaller than number of key times by using the min function. Now we can get the next key time. Key next is key previous plus 1 mod number of key times. Key next is just one more than key previous. To make it cycle back to 0, we mod this by the number of key times. Mod is a division, but only returns the remainder of that division. So as long as key previous plus 1 is smaller than number of key times, the remainder of that division is key previous plus 1. In example, if we have 3 key times from 0 to 3, and key previous is 1, then key previous plus 1 is 2. And 2 divided by number of key times 3 is 0, with a remainder of 2. But as soon as key previous plus 1 is equal to number of key times, mod will return 0, and thus will set key next to 0. In our example, if key previous is 2, then key previous plus 1 is 3. Divided by number of key times, 3. The division is 1, with a remainder of 0, so mod will return 0. Now we need to know how far from key time previous we are. This will be the lerp amount. Var lerp amount is time minus key previous divided by number of key times number of key times. Reading this line again, I had some trouble understanding it, so let's have a closer look. Let's say again we got 3 key times. This means key time 0 starts when time is 0. Key time 1 starts when time is 0.33. Key time 2 starts when time is 0.66 and ends when time is 1. Let's say we're at time 0.5. Then key previous will be 1. So key previous divided by number of key times will be 0.33. Time minus 0.33 will be 0.5 minus 0.33, so 0.166. And 0.166 times number of keyframes, 3, will be 0.5. This means we're halfway between key time 1 and key time 2. And 0.5 is halfway from 1/3 to 2/3. Now all we need to do is lerp the 3 color channels of the 2 colors. Color mix equals lerp color key previous 0, color key next 0, lerp amount. And the same for key previous 1 and next 1, and previous 2 and next 2. Next is the draw GUI event. Here we need to set the uniform so the shader knows what color to tint with, and since we got the color in an array already, we can just pass the array to a vec3. Shader set uniform f array, ucol, color mix. Last thing we need to do is writing the fragment shader. We need to define the uniform vec3 col. Next, let's split the glfrag color line as I always do, but since we're in a post-processing shader, we won't need alpha. So I'll just grab RGB from the GM base texture. vec3 outcol texture 2D GM base texture VV textchord .rgb. And all we now need to do to tint the color is to multiply it with our uniform col and set alpha to 1. glfrag color vec4 outcol times col 1. Now everything is ready for a first test run. This won't look good yet, but we will improve the code a lot from here and add more key times. So the program works. And if we move the slider, you can see the tint changes to what we set in our key times. You can also automate the timer by clicking the automate button beside the slider. One click to run back and forth and a second click to cycle the timer. Now that slider is way too fast. Inside the slider object, I set the step size to 0.002. Now let's just add more key times. I want 8 key times, 1 every 3 hours of a day. I'll just copy and paste those 8 lines from the file in the notes of the project. If you don't use this project, there's a link to a text file in the description of this video, or you can just pause the video to copy the numbers or set your own. Now let's run this again. Looks a lot better already, but still not good enough by far. So now I want to have the possibility to also change contrast, saturation and brightness for each key time. These will not affect the tinting color, but the color of the scene before being tinted. So in Create Event I'll add the uniform handler uConSatBirt for the uniform conSatBirt. And I'll also need a new variable. conSatBirt_mix is -1. This will be an array as well, and like color mix will be a mix of 2 key times and be the values passed to the shader. Now we need to add some parameters to the script add key time. The parameters con, sat, and birt. And like we did with the colors, we need to store those parameters in the new array. Now back in Create Event, let's add some contrast, saturation and brightness to the key times. Again, I'll just copy-paste the values. So here's what I was thinking when setting those numbers. I want low contrasts at night and high contrasts during daytime, especially at noon and afternoon where the sun is brightest. I want some oversaturation at dawn and dusk, but less at night and less at noon. At noon to get the impression of a hot burning sun. And during daytime I want to add some brightness, again to give the sun more strength. Now in Step Event we need to mix those contrast, saturation and brightness values as well. We just do the exact same thing we did with the color mix, but this time with conSatBirt mix. And in Draw GUI Event we need to pass the new uniform as an array again. All we need to do now is make the fragment shader calculate these effects. First we need to define the uniform. This time we're creating an array of floats. In GLSL we need to define the array size right away by setting the size in brackets. So since we pass 3 values for contrast, brightness and saturation, we write uniform float conSatBirt and in brackets 3. Now to make the code more readable, we can use macros like so. Hashtag define contrast conSatBirt 0. The same for saturation and brightness. So from now on, if we write an example contrast in the main function, the shader will replace every mention of contrast with conSatBirt 0 before compiling. Very important though, don't add the semicolons here. Now let's add the calculations. This is pretty much the same as we did in the video on brightness, contrast and saturation, so I'm not going to explain those lines. First we need the gray value of the current pixel by getting the dot product of the color and the NTSC vector. Next we need to add contrast. Since we had defined a macro contrast, this word will get replaced with conSatBirt 0 when the shader is compiled. Then we calculate the saturation by mixing the gray vector with the color. And finally the brightness by adding brightness. Now let's run this again and see if everything works. And again this looks a lot better already. So you can see now we got increased contrast in the afternoon and decreased contrast at night. And morning and afternoon are saturated. But what bothers me now is that the night looks wrong. Usually moonlight reflects on surfaces. And to kind of simulate that effect, I decided to add some moonlight reflection to very bright colors. To do that, I need two new values per key time. One is the strength of the effect and one is the threshold, meaning if the color of a pixel is brighter than the threshold, it gets brightened further by the effect strength factor. So let's add two more columns to our key times in Create Event. One for the effect strength, I'll call it pop strength, and one for the pop threshold. Again, I'm just going to copy paste these lines. As you can see, I increased the pop strength and decreased the threshold during nighttime. Now we need to add these two new parameters to the script add key time again. Pop strength and pop threshold. I'll just use the same array I used for contrast, saturation and brightness. So I'm passing arguments 6 and 7 to the same array. And of course in step event we need two more lines to lerp the key times. But we won't need to change anything in draw event. That code still works. In the fragment shader we need to increase the array size to 5 since we're passing in 5 values now. And we should also add two more macros for pop strength and pop threshold. Then we can add the effect between the contrast and the saturation line. Outcall is outcall plus pop strength times max of gray minus pop threshold and 0. So I'm just subtracting the pop threshold from the pixel's gray value. If the gray value is above the threshold, the max function will return a positive number. If the gray value is below the threshold, the max function returns 0. This multiplied by pop strength is added to the color. So if the gray value is below the threshold, nothing is added at all. But if it's above the threshold, the color's luminance is increased. Now this should work as well. Let's run the program and see how the night has changed. And I like this much more than what we had before. This looks more like a real night. Now let's just tweak the midnight values to see what happens. And you see, pop strength increases the effect and pop threshold gets more colors to pop. Now I'd like to add some star reflection effect to the water. There's certainly better ways to do this, but this way works. First, let's make that reflection layer visible. This is just a tile set with 3 different star tiles. Each is a transparent sprite with some opaque pixels with very light to white values. Let's just run the program and see. So the stars are there, but we need to hide them when the sun is up. As I said, this reflection system is rather crude. What I'm going to do is changing the alpha of the reflection layer to 0 during daytime and 1 during nighttime. But unfortunately, draw set alpha won't change the alpha of a tile layer. So I had to create a shader controlling the alpha and drawing the tile layer through this shader. A bit complicated, but I didn't find another way to set a tile layer's alpha. Anyways, in Create Event we need to get the layer ID of the layer named Layer Reflection. Then we can set a script which runs always before the layer is drawn and one after the layer is drawn. The scripts script set alpha and script reset alpha are already in the base project and we will write them later. And since we want to pass an alpha value to a shader, we need a handler and a uniform. The shader we'll create is going to be called shader alpha and the handler ualpha, the uniform alpha. Now let's write the two scripts. Script set alpha is going to be this: shader set, shader alpha. With object day and night, shader set uniform f, ualpha, alpha. So we set the alpha shader and pass the alpha value. Unfortunately, this layer script is called from the first instance created in the room, and in our case that's the controller object and not the day and night object. So we'll need to refer to the day and night object in here. The second script, script reset alpha, is run after the layer is drawn and is simply resetting the shader, shader reset. Now the shader is extremely simple. All we need to do is define the uniform float alpha, and multiply the pixel color with a vec4 that will only change the alpha, vec4 1 1 1 alpha. But now we need to calculate the alpha in the step event. I wanted some one-line code, and the time of a day should cycle from 0 to 1 as we did with the key times, so I can just use global.slider1 again. Now I could have added an alpha value to the key times, and that would probably have been a better way than what I was doing. But anyways, I'm going to show this because I think it's still an interesting way to do. So now I need a function which returns 1 or more around midnight, 0 or less when the sun is up, and a rather quick tween at dawn and dusk. This will set the alpha for the reflection layer. So I went to a site called desmos.com/calculator, and let's just recreate what I did there. First I set up the axes by giving them a name and a step size. Then I'll just add a rectangle image to have some better visual reference. Then I set up a slider A for amplitude with a range of 0 to 2 and a step size of 0.1. Then another slider S for shift with a range of 0 to 1 and a step size of 0.1 as well. Then a graph just for reference again. Y equals 1. Stupid, I know, but it does help me visualize things. And finally, the main graph. Y equals sinus of x. Now we can see this thing is quite wide. We need to narrow it down by a bit so it ranges from x0 to x1, because x is our daytime. To do that, I multiply x with p. Now we got a function going from 0 to 1 and back to 1 over time. But we needed to go from 1 to 0 and back, because the layer's alpha should be 1 at midnight, so we need to shift the phase by 0.5. But now we can see that the curve is still not narrow enough, so we need to multiply x by 2 to fix that. So this starts to look like what we need. Now we can multiply this with the amplitude factor as we created earlier and shift by S and use the sliders of A and S to find values that look like what we want. So A at 1.6 and S 0.1 looks about right. Since I don't know a better way to copy that function from Desmos, I'll just copy with Ctrl+C and paste that into GMS, but you'll see what happens. Unfortunately, this looks quite ugly and we need to fix this first. Y is sine 2 times x plus 0.5 times 3.14 times A minus S. Now we can replace Y with alpha, X with global.slider1, A with 1.6 and S with 0.1. As we have seen, the function returns values above 1 and below 0, so we just clamped this to 0 and 1. But this should be it already. Let's run the program and see the stars reflecting in the water at night. And now you can see the reflection coming up at night time and going away again when the sun rises. Shortly after I had finished editing this video, I tried another way to blend the daytime color with the image, and I liked the result. So I'm going to add a shorter video showing the Photoshop blend mode overlay and how to implement it into GMS and our day and night shader. Until next time.